Lesson 3, solving triangles and trig word problems. Let's start with a warm-up to review what we learned yesterday about the primary trig functions. So let's start by writing SOHCAHTOA here. For the first one, we are solving for angle A. Let's label the two sides that we know. This side on the left is opposite from angle A. The other side is across from the 90-degree angle, so it is the hypotenuse. Then using SOHCAHTOA, we see that sine has opposite and hypotenuse, so we want to use the sine function. Sine theta equals opposite over hypotenuse is the sine trig function. Then we plug in our information. Our angle is called A. I could leave it theta, or I can write A there. Sine A equals, the opposite is 175 over the hypotenuse, which is 340. Then we want A, not sine A, so we're going to take the sine inverse on both sides, which would then leave us with A equals sine inverse of 175 over 340. And now we plug it into our calculator. So shift sine to get sine inverse, bracket 175 divide 340, close bracket, and then equals. And we should get 30.9777. With angles, we usually round to the nearest whole number. So that would be 31 degrees. For the next one, we're solving for a side length. So from our angle that we're given, let's label the side we have and the side we want. So the side we have is opposite from our given angle, and the side we want is adjacent from that angle. Opposite and adjacent, that's TOA, so we're using the tan trig function. Tan theta equals opposite over adjacent. Remember, you can always reference these on your formula sheet. You want to make sure that you get the order correct. Then plug in our information. Tan of 15 equals, the opposite side is 1.5 over the adjacent side, which is r. Then we want to solve for r, so we can cross multiply by putting a 1 under the trig function and then cross multiply and divide. So 1 times 1.5 divided by tan 15 gives me r equals 5.5980. With side lengths, we typically round to the tenths place, so 5.6 centimeters. To solve a triangle means to determine the measures of all the missing angles and the lengths of all the missing sides. So we're not really doing anything new with this information. We are just using what we learned in the last lesson or prior, like Pythagorean theorem, to find all missing sides and angles. So let's solve the following. A couple things to keep in mind whenever we're solving a triangle is we want to try to use the given values for all calculations. And keep 4 numbers after the decimal, if you need to use a calculated value for further calculations. A, we are given angle B, it's 42 degrees, and we are given side B, which is 15. So based on angle 42, side B is the opposite. I need to find the other two sides and the one missing angle. So the angle's pretty easy because I know two angles already, and I know that the three angles in any triangle have to add to 180. So I'm going to solve for angle A first, starting with 180 degrees, subtract 90 degrees for angle C, subtract 42 degrees for angle B, plug that into my calculator, 180 minus 90 minus 42 gives me 48. So angle A equals 48 degrees. Now I need to solve for the sides, so it doesn't really matter which one you start with. I am going to start with the adjacent, which is side A. So I've got the opposite, I want the adjacent. That means I'm going to use tan. Tan theta equals opposite over adjacent. Plug in my values. Tan of the angle 42 equals, the opposite side is 15 over the adjacent, which is A. I can put a 1 under my trig function and then cross multiply and divide. So 1 times 15 divided by tan 42. That gives me 16.6591. Rounding to the tenths place for side lengths is 16.7. And then lastly, we need side C, which is the hypotenuse. Now here's where this point about try to use the given values for all calculations, this comes in. So I'm not going to use this adjacent that I just calculated. I'm going to use the opposite because that was given to me, and I'm going to calculate the hypotenuse. So opposite and hypotenuse, that tells me to use the sine trig function, and this is for side C. So sine theta equals opposite over hypotenuse. Then plug in our values. Sine of angle 42 equals, the opposite is 15, over the hypotenuse, which is C. I can put a 1 under my trig function and then cross multiply and divide. So 1 times 15 divided by sine 42, which gives me C equals 22.4171, which is 22.4 to the tenths place. So we've solved the triangle because we found all the missing sides and the missing angle. Next one, we have two sides of a right triangle. This is 31 meters. we need to find the missing side and the two missing angles. So I'm going to start with the side. I have two sides of a right triangle. That means I can use Pythagorean theorem to find the third side. The third side in this case is the hypotenuse because it is across from the right angle, and it would be called lowercase d. So side d, using Pythagorean, which is a squared plus b squared equals c squared, where c is the hypotenuse. So in this case, we'd have 31 squared plus 42 squared equals d squared, since d is our hypotenuse. Then we want d, not d squared, so we take the square root of both sides to get square root bracket 31 squared plus 42 squared close bracket equals d. And then we calculate that. Square root bracket 31 squared plus 42 squared close bracket gives me d equals 52.2015. Rounding side lengths to the tenths is 52.2, and this is in meters. Next, I'm going to choose to solve for angle E. So based on angle E, I'm going to label the two sides I have. 31 meters would be opposite from E, and 42 meters is adjacent to E. Angle E then, we're going to use tan. Tan theta equals opposite over adjacent. Fill in our values. Tan E equals, the opposite is 31 over the adjacent, which is 42. Then we want E, so take tan inverse of both sides to get E equals tan inverse of 31 over 42. And plug that into your calculator. Shift tan bracket 31 divide 42 close bracket equals, we get 36.4308. I can't remember if I said this already, but make sure your calculator's in degree mode. If you're getting answers that are not these, it's probably because your calculator is not in degree mode. So round to the nearest whole number 4 degrees, so 36 degrees. Next, solve for angle F. I'm just going to change my color here. So angle F, again, label the two sides that we have based on angle F. So side 42 is opposite from F, and side 31 is adjacent to F. So notice how from our angle E, this was opposite, and now from angle F, it switches and becomes the adjacent. And same thing over here. 42 was adjacent to E, but from F, it is opposite, okay? So essentially, we're going to be doing the same thing that we did to calculate angle E, but our fraction is going to flip upside down because our opposite and adjacent have just swapped. So for angle F, we have tan F equals 42 over 31. So our opposite is 42, our adjacent is 31 for angle F. Then we take tan inverse of both sides to get F equals tan inverse of 42 over 31. And then we calculate. Shift tan bracket 42 divide 31 close bracket, equals. And we get F is 53.5691. Rounding to the whole number for angles would give us 54 degrees. And we could double check our angles. We know that they need to add to 180 in any triangle. So we've got 90 degrees plus E, we calculated to be 36, plus F, we calculated to be 54. Add those together, and it gives us 180. Word problems. First, you need to draw and label a diagram when you're doing a word problem. First example, at what angle to the ground is an 8-meter long conveyor belt if it is fastened 5 meters from the base of a loading ramp, round to the nearest degree? So we know we're working with right triangles. We're always going to be drawing a right triangle. Our conveyor belt is like an escalator. It's taking things up. So it's this part, the hypotenuse. And it says that it's an 8-meter long conveyor belt. So our hypotenuse is 8 meters. It's fastened 5 meters from the base of the loading ramp. The loading ramp would be up here. This is where we're trying to get the items to, is to the top of the triangle. So 5 meters from the base. So base means bottom. So down at the bottom where that 90-degree angle is. 5 meters away is where our conveyor belt is attached. So here's the base of our loading dock, or whatever it was called, loading ramp. And then here's the distance to where the conveyor is attached. That distance is 5 meters. We want to know at what angle to the ground is it attached. So at what angle to the ground? That is this angle. That is what we're looking for. I'm going to call that theta. Once I've got a diagram, the next step is to label things. So this would be the adjacent side, and the 8 meters would be the hypotenuse. Then we want to decide which trig function we're going to use. Adjacent and hypotenuse, that is cos. I'm going to write SOHCAHTOA up here. So adjacent and hypotenuse is cos. Cos theta equals adjacent over hypotenuse. Next, we want to plug in our values. Cos theta equals, the adjacent is 5, the hypotenuse is 8. And then we want to solve. So in this case, we're finding an angle. We're going to do cos inverse of both sides to get theta equals cos inverse of 5 over 8. And then we're going to plug that into our calculator. Shift cos bracket 5 divide 8 close bracket equals, and I get theta is 51.3178. Round to the nearest degree is 51 degrees. Then it's a word problem, so we should write at least a sentence or a point form note. So the angle to the ground is 51 degrees. Next, a ladder leaning against the wall forms an angle of 63 degrees with the ground. How far up the wall will the ladder reach if the foot of the ladder is 2 meters from the wall? Round to the nearest tenth of a meter. So start by drawing a right triangle. And then labeling our information. A ladder leaning against a wall forms an angle of 63 degrees. Obviously the wall should be straight up and down. So this would be the wall. The ladder leans against the wall, so the hypotenuse would be the ladder. The ladder forms an angle of 63 degrees with the ground, so this would be where our 63 goes. How far up the wall will the ladder reach? That would be here. We're calculating x. If the foot of the ladder, so foot and base always mean bottom, so the bottom of the ladder would be here. The foot of the ladder is 2 meters from the wall. Distance between the wall and the bottom of the ladder is 2 meters. Now that we have our triangle drawn, we're going to label the side we want and the side we have. So from angle 63, x would be the opposite side, and 2 meters would be the adjacent side. That tells us to use TOA or tan. Tan theta equals opposite over adjacent. Plug in our values. Tan 63 equals the opposite is x, and the adjacent is 2. When solving for a side using a trig function, we cross multiply and divide by putting a 1 under the trig function. So tan 63 times 2 divided by 1. Tan 63 times 2 in our calculator gives us x equals 3.9252. Round to the tens place is 3.9 meters. And then write a little sentence. The ladder reaches 3.9 meters up the wall. Next example, at what angle to the ground, to the nearest degree, must you place a support if it is 6.8 meters long and must reach 4.2 meters up the side of a tower? So right triangle. The tower should be the vertical line. The support would be our hypotenuse. So at what angle to the ground, we want to know what is this angle here. So I'm calling that theta. At what angle to the ground, to the nearest degree, must you place a support if it is 6.8 meters long? So the support itself is 6.8 meters. That means our hypotenuse is 6.8 meters. And must reach 4.2 meters up the side of the tower. So this is 4.2 meters. From our angle that we're trying to solve for, label the two sides. 4.2 would be opposite, and 6.8 is hypotenuse. Then we would use from SOHCAHTOA, sine theta equals opposite over hypotenuse. Plug in our values. Sine theta equals 4.2 over the hypotenuse is 6.8. Then we want to take the inverse sine of each side, and we get theta equals sine inverse bracket 4.2 over 6.8, close bracket. Then we're going to plug that into our calculator. Shift sine bracket 4.2 divide 6.8, close bracket, equals, and we get 38.1445. And then round to the nearest degree, 38 degrees. Then write a little statement. The angle must be 38 degrees. Angle of elevation. This is the angle between the horizontal. Remember, a horizontal is a line that's going like this, and the line of sight from the observer up to an object. So here's a picture of that. We have an observer here. We've got a horizontal. So if they were to look straight, that creates our horizontal. Then we have an angle looking up to a line of sight from the horizontal, and that is our angle of elevation. Angle of depression is the angle between the horizontal. So here's our horizontal. And then if the person looks down from the horizontal to create a line of sight downward, the angle between the horizontal and that line of sight is the angle of depression. Let's add a note here. When we have a Z shape like this, where we've got a horizontal at the top and the bottom, here's our angle of depression, and here is our angle of elevation. When we have a Z shape, the angle of depression and the angle of elevation are equal. Example 5, the string of a kite is 105 meters long. The string is anchored to the ground. The kite is 90 meters high. Determine the angle of elevation of the string to the nearest degree. Draw me a triangle. The string of a kite is 105 meters long. Kites don't fly straight up if you've never flown a kite. Here's the person flying the kite. The kite would be over here because the wind is going to blow it one direction or the other, so it's not going to be directly above a person. So our kite string is 105 meters. That's going to be the hypotenuse of the triangle. The string is anchored to the ground. The kite is 90 meters high, so vertical distance is 90 meters. Determine the angle of elevation of the string to the nearest degree. So remember, angle of elevation goes from the horizontal and then up to the line of sight. So this angle down here is our angle of interest. I'll call it theta. Label the two sides we have based on theta. 90 is the opposite and 105 is the hypotenuse. Then I'm going to write SOHCAHTOA up here again. Based on the fact that we have opposite and hypotenuse, that means we're going to use sine theta equals opposite over hypotenuse. Plug in our values. Sine theta equals 90 is the opposite over 105 is the hypotenuse. Then we take the inverse trig function, so sine inverse of both sides to get theta equals sine inverse of 90 over 105. And then we calculate shift sine bracket 90 divide 105 close bracket equals 58.9972. Round to the nearest degree gives us 59 degrees. And then write a sentence. The angle of elevation is 59 degrees. Example 6. Nika is rock climbing while Ross is belaying. when Ross pulls the rope taut to the ground, the angle of depression is 73 degrees. If Ross is standing 8 feet from the wall, what length of rope is off the ground? So draw your triangle. In this case, it says angle of depression. So angle of depression goes from the top of your triangle. So I'm going to draw a horizontal line there. Angle of depression is here, looking down to the line of sight. So that's 73 degrees. But we said on the last page, when we have a Z shape like this, the angle of depression and the angle of elevation are equal. So this is also 73 degrees. Let's label the rest of it. Is if Ross is standing 8 feet from the wall, what length of rope is off the ground? So Ross would be standing here. This is Ross. And the wall would be over here. So the distance between them is 8 feet. We want to know what length of rope is off the ground. The rope is the hypotenuse there. And then our 8 feet would be the adjacent from 73. So adjacent and hypotenuse. So ka toa, that would be ka. Cos theta equals adjacent over hypotenuse. Fill in our numbers. Cos 73 equals, adjacent is 8. Hypotenuse is what we're trying to find, so x. Put a 1 under the trig function, and then cross, multiply, and divide. 1 times 8 divided by cos 73, which gives me 27.3624. And it doesn't say where to round to, but for side lengths, we typically do the tenths place. So let's say 27.4 feet. And then lastly, write a statement. So 27.4 feet of rope is off the ground. That's it for the lesson. So now do the practice, and tomorrow we're moving on to lesson 4.